Hello everyone, I hope I find you well. Welcome to my YouTube channel. Thank you for your support. For this channel to grow, I need your support and I need your help, and I am seeing that support. Once again, thank you. In this video, we are dealing with bearings. Okay, we've got a question here which says Ben and Tom are standing together. Tom walks 20 meters from Ben on a bearing of 293 degrees. He turns and looks at Ben. What is the three-figure bearing of Ben from Tom? Okay, that's our question. Two guys are standing together and one of them moves away from the other, which is Tom in this case, at a bearing 20 meters at a bearing of 293 degrees from Ben. So Tom turns and looks at Ben. So we want to find the three-figure bearing of Ben from Tom. So I've put a diagram here to help us to find the solution. So this is Ben's position. This is now Tom's current position. But previously they were together here. Okay. And Tom walked away 20 meter stretch. This one represented by this line, by this transversal. So Tom walked from Ben 20 meters at a bearing of 293 degrees. Remember, in this video we are dealing, by the way, we are dealing with three-figure bearings. Okay, so there are about three important rules on three-figure bearings. If you watch my previous video on bearings, the first one says that we must always measure starting from north. We measure our bearing starting from north, and we measure clockwise, not counterclockwise this way, but we measure clockwise like this, as indicated by this arrow. And also we use 3 digits, but already 293 degrees always has got 3 digits already. Okay, but any angle less than 100 degrees we must put a zero, a prefix a 0, so that it can have 3 digits. Okay, so I've drawn the diagram here which represents the current positions of the two boys. Tom is now here, Ben is now here. And we want to find, according to the question, what is the three-figure bearing of Ben from Tom, So Tom is our reference point in this case. Okay, Tom is our reference point. So we draw a north line or north arrow from the Tom's position. These are parallel to each other. Okay, these north lines. We draw a north line at Tom's position. So the bearing of Ben from Tom is the angle which starts from this north line. Tom is our reference point, from this north line up to this line which goes to Ben. So we need to find the size of this angle. Okay, let us come to this box before we answer the question. Let's go to this box. It says co-interior angles occur in between two parallel lines when they are intersected or joined by a transversal line or transversal. The two angles that occur on the same side of the transversal always add up to 180 degrees. So let me just use this diagram. This is the transversal which is being referred to. Okay, these are the two parallel lines, these north arrows, which are joined by this transversal. So what is being said is that the angle between this north line and this transversal, and the angle between this north line and this transversal they add up to 180 degrees. Okay, so for me to find the bearing of Ben from Tom, I must find the size of this angle here between this north line and this line which goes to Ben. Okay, so how can I get this line, this angle? First of all, if I get this one, the size of this angle, I will then find this one. So from here up to here is 293. So what's the value of this angle? Remember, here is 360 degrees, one revolution. So I will say 360 degrees minus 293. What do I get? 360 degrees minus 293, I get 67 degrees. So here is 67 degrees. Okay? So since this angle and this one are co-interior angles, they add up to 180 degrees. So for me to get the side of this angle, I will say 180 degrees minus 67 degrees, which is 113 degrees. Okay, this 113 degrees. So okay, so the side of this angle will be 113 degrees. So that's the bearing of Ben from Tom. Okay, so the bearing of Ben from Tom is 113 degrees. Okay, thank you for watching, guys. Meet you in the next videos.